Instead of step and repeat, you can copy and paste. So you can do, if there's only a 3 panel array, it's probably quicker just to copy, paste and paste. Okay, so using the same program as we use for the step and repeat, we do exactly the same start point, panels and blocks, copy, draw the box around the panel, and then just move to the top left of the next panel you want to paste onto, okay, like so, and say panels and blocks, paste. It will automatically give you number 2 for the second panel, and okay. And you just drag the boxes to the location using the arrow keys, get it as close as you can, like so, and okay. And then just move to the next panel and do the same, panels and blocks, paste, number 3, and so on. Okay. And just like moving, if you have to manually move a panel, I'll show you how to do that at the end of this video, okay? This panel, obviously we would use paste panel array, but I'm just showing you the different options for copy and paste. If you have a panel with a bad bend in it, a bad bow, sometimes it's better to do the step and repeat this way. So just remember, always top left before you paste. You must do each panel individually this way. You cannot do a copy of the bottom array and then paste it on top. It will work, but it will be one panel. It won't be individual panels if you do that. Okay. So it takes a little bit longer, but it's just another way to do it. Okay. So, and I'll make one of them badly off so that you can see how you fix it. Okay, so the next one we do, I will place quite low in position. Okay, so just continue on until you're finished. And we will fix it at the end. Do not complicate it. Okay, so all 10 are done. If I go back to this panel, I can move in closer, get to a location you can see, make the map active by clicking on the map, then say panels and blocks, move, draw the box around the panel in question, like so, and then just move on the screen. So always try and use the highest magnification in a light that you can see, and that moves the whole panel back into position. Okay. Debugging your newly created program. Press the play button on the toolbar, run, do an offline inspect, and this is to help you tweak and adjust the program slightly so that you get few false failures. We have got positions on the board that are not being inspected for any devices, so we will quickly reduce those scores, positional check, anything that's making it fail. You can also see we have some lead bridges. Usually that means the parameters have to be changed. So if we review the failures, this one is definitely missing. Shows us what should be there, what is there. So R165 is missing and failed. Okay, this guy is scoring 547. It's only the first board. 600 is the threshold, as you can see. We will accept it. Okay, so we have a lead bridge. So if we right click and test, it says maximum width 77.75, worst regularity 12.34. Regularity failure usually suggests if it's over 10% it may be the wrong pitch in the parameters, but as you can see the parallax is twisting the board, the leads slightly, so we can measure the leads from pad to pad 25 mils. Okay, that's correct, that's correct as well. So maybe we want to up the parameters to 15 and to 78. Don't go over 80 on this, and test. And now we pass. Okay, to see where it's failing, take it back down to 75 and test, and if it's the final lead, then use double width ends. If you've changed parameters, you can right click, update lead area, same package type, OK, and that's all of that package will have those new parameters. So we can just double check, test, pass. Remember, we're not checking for solder, but as you can see on this guy, that lead looks badly damaged, so we'll fail that. And now you see this is passing. Okay, so just by changing those parameters, we now have this device no longer failing all of those fails, and that was responsible for a very high number of the failures on the board. Okay, doesn't look very good, that one either. Okay, I want to check the other side, so just be careful what you're doing. Okay, because that 75 is maybe too high, so maybe take it to 65. Update lead area, same package type, because we want to find a shifted device. Now it finds it. Okay, very subtle fault, so we can fail shifted device, and instead of saying fail we can say next part, and that fails all the leads. Okay, it will always step through the failed devices. Okay, this guy here, he's not testing anything, he's got a 0 test on it, but he's got a positional check which we want to take off. Okay, you can also delete these from the program, but there's no need. Okay, if they have a 0 score, 0 positional check, then they're not doing anything. This guy's wrong polarity, U18, 0 score. The image is facing the opposite direction from the device, so that's a definite wrong polarity and fail. If you get a 0 and it's facing the right way, it's usually the search area is not big enough. You can increase the search area and test, and then you see it passes and the white box locks onto the part number. Okay, so we have here U20. It has a lead bridge because the parameters are wrong. We will delete the lead inspector from the SOT25 for the 2 pins only and update the package to show that, and move on. So most of the failures were due to parameters being wrong, not due to any false failures, but we have a couple of false failures on the board like so for bad marking, okay, and we have a skewed device or shifted, whatever you want to call it. This device is scoring U3, no problems, it's a lead inspection. We can also print those results, so if we fail, 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 it also gives you a map of the failed areas for rework.